This is homework number 4. This is the transformations unit review. So the first problem is a translation. Okay, so the vertices of triangle MNO are as follows. So M is -2, 4. Oops, let's use a different color. -2, 4 is going to be M. -1, 1 is N. And O is 3, 3. Okay, so here's our triangle MNO. Okay, graph and label the image of the triangle using prime notation. So this is our pre-image. Once we translate it, then the translated version will be our image. The pre-image comes before, and then your image is your second. Okay, so we can do this 2 ways. We can do this by counting it out on the graph or by substituting in our points into our rule. We can do it both ways. So let's count it out first. So this 4 is going to give us our horizontal shift, and the -6 is our vertical shift. So it's a positive 4, so we're going to go right 4, and that's -6, so we go down 6. So we can just count this out. We want to go right 4 and down 6. I'll do this one in blue. Okay. 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6 down. Here's M prime. 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6 down. That's going to be O prime. Then 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6 down. Here's N prime. The other way we could have gotten those points is we could have substituted in our originals. So we could have done -2, 4. So our originals were -2, 4, -1, 1, and 3, 3. And they are all going to get translated. And then all we're going to do with our original points is simply substitute them into the equation. So it's going to be -2 plus 4. And then 4 minus 6. So that's going to give us 2, -2. And if we look over here for M prime, it's 2, -2. -1, 1 here. So we would plug it in. -1 plus 4. 1 minus 6. That's going to give us 3, -5. So exactly what we got for N prime there. And then the last one here, substitute it in. So it's going to be 3 plus 4, and then 3 minus 6, which should give us 7, -3. And we have 7 over, 3 down is O prime. Simple enough. Number 2 asks for reflections. So reflecting, we're flipping over some line. And this review has all the different lines we can reflect over. So the first one is the x-axis. Okay, that's our horizontal axis here. If they gave us the points, we could have changed the signs. So we could count this out. So this is 2, 2. Okay. We know if we reflect over the x-axis, what's changing is the y's, right? The x are all staying the same, but because these points are getting flipped down, or points down here get flipped up, we're changing the sign of the y. So this would become 2, -2. So we can either flip, this is 2 units above, so we need to go 2 units below, or we can use our rule, which was xy goes to x -y. Okay. So this one's 3 above, so we go 3 below. This one's 1, 2, 3, 4, 5 above. 1, 2, 3, 4, 5 below. Okay, we could also put these all in. This is 4, 5. All right, so that's going to go to 4, -5. It just comes down. This one is 6, 3. It's going to go to 6, -3, because we're just flipping it down. The next one here is reflecting over the y-axis. So this is the y-axis right here. It's the horizontal axis. If we're reflecting over it, Again, we can just count. This one's 1 to the right, so we need to go 1 to the left. 5 to the right, so we need to go 5 to the left. Okay, 2 to the right, 2 to the left, 4 to the right, 4 to the left. Okay, we could also use the rule though. The rule is xy goes to negative xy. So what's changing here are x's. The y's all stay the same. It stays at the same level. Think of it as the same latitude, and then the longitude is what's changing. So you can find these points, for example, this would be 2, 1. And that's, if we follow our rule, that's going to become negative 2, 1, which it does. Okay. Reflect over line x equals 2, so that's a horizontal line at 2. So you want to find your x-axis, and you want to find 2 on your x-axis, and then draw a vertical line. So the reason this is x equals 2 is because for every point on this line has an x value of 2, right? This is 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7. So every point on that line has an x value of 2. So we just call it x equals 2. If we reflect over, it's the same process. That we don't have a specific rule for each of these. We have to use the counting. So this point's 1 to the left, so we need to reflect it 1 to the right. This is 4 to the left, so we need to reflect it 4 to the right. 1 to the left, so we need to go 1 to the right. 4 to the left, we need to go 4 to the right. And that's how we reflect over x equals 2. Okay. Y equals negative 3, so we go to the y-axis. Find negative 3 on it. Okay, and we draw a horizontal line. Because y equals 3 is a horizontal line. Every value here is negative 3. So this point is 1, negative 3, 2, negative 3, 3, negative 3, 4, negative 3, 5, negative 3. And since every point on this line has a y value of negative 3, we call it y equals negative 3. It's got a slope of 0, and the y-intercept is negative 3. All right, so this point right here is on the line. So since it's on the line, it stays on the line when you fold it over. This point right here is 1 above, so we need to go 1 below. 4 above, so we go 1, 2, 3, 4 below. Okay, and those are going to be that's our reflection over the line y equals 3. Symmetric on each side. Okay, the next one, y equals x. So here is our line, y equals x. Okay. Our rule for y equals x, we need to use the rule here, is xy is going to be reflected to y-axis. So we're simply switching the coordinates. So we need to find the coordinates first. So the first one here is 1, 2. So the blue one here, 1, 2. So that's going to become 2, 1. This one here is negative 3, 3. So it's going to become 3, negative 3. And the last one is negative 1, 2. I'm sorry, negative 2, 1. So it becomes 1, negative 2. Switch the coordinates. Okay. And here's our new one. Looks a little off, but I think it's because the board stretches vertically, and I didn't draw it very well. And then I also plotted wrong. No, I didn't. Nope, we're good. The reason it looks like this is because the board, this board stretches vertically. Okay, the computer screen is a rectangle. The board is a square, so it projects. It stretches up. It has a vertical stretch. So if we were to stretch it back down, so each of these squares, see, these look like rectangles more than they do squares. If you made this a square, these would line up. Yeah, I mean, it's right. It just looks a little off because of the board, the projector. Okay, and then we said you guys didn't have to do the y equals negative x1. We're just going to worry about y equals x. So we can go on to number 3. Okay. Number 3 here, we want to write a rule. Okay, we also probably want to be able to do it in vector form. So our rule would be as follows. We need to find our horizontal shift and our vertical shift and fill them in. Okay, so we're going to have to fill in the rest here. So our horizontal shift, we're going 1, 2.5. So we're going 2.5 to the right, and we're going 1 down. So again, you pick 2 of the same pre-image and image points, right? So D and D prime, E and E prime, or F and F prime. Those are the ones you want to pick. It'll work for any of them. But we're going 1, 2, 2.5 to the right, and 1 down. So the horizontal shift is 2.5 to the right, which is a positive 2.5, and it's down 1, so it's going to be -1. So there's our rule. XY goes to x plus 2.5, y minus 1. Right, and again, this is the point coordinate. If we wrote that as a vector, it would be 2.5, -1. And again, the vectors show us the distance and the magnitude and direction that we're shifting all these points. Okay. Number 4, they're giving us the reflections. We need to find the new point. I believe. Okay, given the following coordinates of a point in a line of reflection, determine the coordinates of the image. So if we know the rules, these are pretty easy. So a rule for reflecting over the x-axis is xy goes to x negative y. So we're simply going to make this 3, 5. Okay, switch the sign on the y. Okay. The other way we can do it is we can draw it out. So point 3, -5 is down here. So if we reflect over the x-axis, which is this axis right here, is our x-axis. It's going to end up coming up here, so we know it's going to be positive and positive. The 3 is going to stay the same, the 5 is going to become positive. Okay, the next one we're reflecting over the y-axis. So again, our rule here is xy goes to opposite of x, y. So we change the sign on the x, it becomes 2, and then we're left with 2, 7. Again, if we wanted to graph it, -2, 7's up here. Reflecting over the y-axis. So it's going to come over to this quadrant, so it's going to be positive, positive. 2 stays the same, 7 is the one that's reflected over, it changes signs. Okay. Our rule for y equals x is simply switch the coordinates. Right, so 4, 6 is going to become 6, 4. And again, if we wanted to look at that, 4, 6, right, it's going to become 6, 4. It's hard to do it on a graph without lines, but yeah. Okay. These ones are, well, D is the y equals negative x, which again we didn't talk about, so we can just skip over that one. It's really not too difficult. You're switching them and you're changing the signs, but that's okay. We don't need to worry about it. Let's go on to the y equals 3 then. So here we go. We have a line y equals 3. So that's a horizontal line at 3 on the y-axis. We're looking at the point 3, 1, which would be somewhere here. So right now we're 2 units below. Okay, we need to go. This is at y equals 3. So if we flip it up above, it's still going to be 3. We're 2 units below. We need to go 2 units above. So now we're going to be at 5, 3, 5. Maybe a little easier to do on a graph paper. So if you don't understand this, put it on an actual grid and see if you get it. And then this one here, we're reflecting on the line x equals -5. So that's somewhere here. Okay, we're at 8, -3. Okay, we're reflecting over this line. So we come over here. The -3 is going to stay the same. Okay, we have to travel 13 units to get to -5. So that means we're going to have to travel 13 more. Probably should do the blue or something. Okay, so we got to travel 13 units. 13 units. So we're going to have to travel another 13 units. So -5 minus 13 is going to give us -18. So it's going to be -18, -3. And again, that would be much easier to look at if you had graph paper or some grid to plot it on. But you have, this is 13 units away. This is 13 units to the right. Your reflection needs to be 13 to the left. So that's going to be your y is going to stay the same. It's going to have to be 13 to the left of -5, 13 to the left of -5, which is going to be -5 minus 13, which gives us -18. Okay, now the hard ones here, not hard ones, but the ones where you guys struggle, rotating. So let's do our rotations. So the rule for 180 is xy goes to -x, -y. We just simply change the signs. All of these, or this one's on the y-axis. So if we go 180 around, you're fine. Okay, 180 around is going to put these here. But let's plot out our points first. So let's plot these points out. Or I mean, write the coordinates out. So this is 0, -1. H is -3, -5. And J is -5, -3. So all we do here is change our signs. So this becomes 0, 1. This becomes 3, 5. And this becomes 5, 4. So Q prime is 0, 1. H goes to H prime, 3, 5. H prime. And J goes to J prime, 5, 3. So here is J prime. So there's our triangle. Okay. We've rotated it 180 degrees. Right, halfway around the halfway around. Okay. Number 90 here. I'm sorry, number 6. We're going 90 counterclockwise. So our origin's here. So our rule for this, again, we had 2 steps. Right. One is switch the coordinates. Let me erase so we have room to write though. Okay, one was switch the coordinates. Right. And again, remember the reason we're switching coordinates is because you have to imagine this is going around a circle. So for example, this one is 4, 5. So it's not going to -4, 5 because that's not 90 degrees. It's going to go 90 degrees. It's going to be at -5, 4. Okay, so switch the coordinates. And then 2 is find the signs. And we find the signs by looking for which quadrant we go into. Okay, so let's look at B. We just said was 4, 5. Okay, so first step here, switch the coordinates. Okay, 5, 4. Second step, figure out the signs. So B right now is in quadrant 1. If we want to go counterclockwise 90, we're going 1 quadrant to the left. So that's going to be quadrant 2, and the signs for quadrant 2 are negative and positive. So -5, 4, which is B. S is 2, 2. It's a little hard to tell. Okay, switch the coordinates. So 2, 2 is still 2, 2 because they're same. Right now it's in quadrant 1. If we go 90 degrees counterclockwise, we're going to be in quadrant 2. And quadrant 2 is negative, positive. L, is that an L? L is 5, 0. Step 1 here is switch the coordinates. Okay, if we go, we're on the x-axis. So if we go 90 degrees, we're going to be on the y-axis. So it's just going to be 0, 5. So that's going to be L prime. Then negative 2, 2 was S prime. So there we go. Each of these has gone around. Okay, imagine a circle going all the way around. A quarter of the way around, 90 degrees around. It's shifted 90 degrees. Okay. Use the translation, xy goes to x plus 3, y minus 2. What is the image of negative 1, 5? Okay, so the image we just substitute in. So negative 1, 5 goes to negative 1 plus 3, 5 minus 2. So that's going to be 2, 3. Okay, and you can put this on a graph and check it. Right, if you were at negative 1, 5, you go 3 to the right, you should be at 2. And if you go down 2, you should be at 3. So that one works. Okay, pre-image. So this is like having our final. 4, 4, 1 is our image, so that's our final. Now we need to find the pre-image. So we got to find the original. So after we added 3 and subtracted 2, we got negative 4, negative 1. Okay, after we added 3 and subtracted 2, we got negative 4, negative 1. So we want to work backwards. So we basically want to subtract 3 from this and add 2. Right, that puts us at negative 7 and 1. So that's our image, pre-image. Okay, we can plug it in to check it though. So negative 7, 1. Okay. Negative 7 plus 3 is going to give us negative 4. 1 minus 2 is going to give us negative 1. So we're good. Negative 7, 1. You just got to kind of work backwards. Think about it and work backwards. Okay, do the opposite. Subtract 3 and add 2. 8, 9, and 10. So number 8 here, the vertices of triangle ABC are as follows. How are we doing on time? 23. Took a long time to explain that. I don't know. I never know how much detail I should go into. Who's watching the video, who's not. Okay. Vertices of triangle ABC are A, negative 4, 4, negative 5, 0, and negative 1, 3. Okay, we want to translate it using the equation here. So we want to move all these 6 to the right and 1 down. So 1, 2, 3, 4, 5, 6, and 1 down. There's A prime. Let's use a different color. 1, 2, 3, 4, 5, 6, and 1 down is A prime. 1, 2, 3, 4, 5, 6, and 1 down is C prime. 1, 2, 3, 4, 5, 6, and 1 down is B prime. We could have also substituted those into our rule, whichever way you find easier. Okay. The next step here is to reflect the image over the y-axis. So this is our y-axis. This is what we're reflecting over. Right now, A is 2 to the right, so A prime is 2 to the right, so A double prime. Right, this is going to be A double prime. Okay, C is 1, 2, 3, 4, 5 to the right. We need to go 1, 2, 3, 4, 5 to the left. That's going to be C double prime, and then 1 to the right, so 1 to the left. That's C double prime. I'm sorry, B double prime. Okay. There we go. We translated it, then reflected it over the y-axis. We're good. Okay, number 9. We want to dilate with a scale factor of 2. So scale. So let's write our original points here. F, D, and E. What do we got? E is 0, -2. It's hard to see from an angle. You gotta kind of back up. -2, 2. And 2, 3. So scale factor is we're moving it away from the origin by a factor of 2. So basically we're multiplying all of these coordinates by 2. So this is going to become 4, 6, -4, 4, and 0, -4. So E prime is here, D prime is here, and then F prime is 4, 6. Okay, so we move everything twice as far from the origin. Easy enough. Let's look at 10. Okay, we want to dilate with a scale factor of 1/3. Okay, so basically we're getting 1/3 as far from the origin, or you can think of it as 3 times as close. 1/3 as far from the origin, which is maybe closer, right? 1/3 as far as closer, or you can think of it as 3 times as close. Okay, so let's write our coordinates here. It's 3, 6. Hopefully everything is a multiple of 3. That's -3, 3. And that is 6, -3. So multiply by 1/3 or divide by 3. Same idea, right? Multiplying by 1/3 is the same as dividing by 3. So we have 1, 2, -1, 1, 2, -1. So 2, -1, -1, 1, and 1, 2. Okay, that would be our dilation. It's really more of a contraction, right? You're contracting. Negative dilation. All right, we're good there. And then the last one, this would be your level 4 type question where you're constructing your own. Okay, let's see. All right, so what I'm going to do is I'm going to read the directions here off. Well, it's going to be a little difficult. Okay, let's look at our rules first. I'll tell you what I'm going to do first. Okay, so what I'm going to do here is I'm going to pick 3 points, A, B, and C. Okay, I'm going to translate the figure according to this rule. I'm going to do xy goes to x plus 5, y plus 4. Okay. Then I'm going to reflect the translated figure over the line y. Let's go over the y equals. You can do the y-axis to make it simple. I'm going to make it a little hard. Let's do x equals -2. Okay. Then I'm going to rotate 90 clockwise. Right, then I'm going to dilate by 1/2. So my scale factor will be 1/2. Let's see if I can remember that. Plus 5, plus 4, -2, 90 clockwise, 1/2. So let me pick some points here. I think it's at A, B, and C, right? Yep, so it's called A, B, and C. So I'm going to pick points here, here, and we'll say here. Well, it'll be fun to do a cross one. Let's do here, here, and down here. Just to be a little more fun. So let's do A, B, and C. Okay, so we're going to translate this. 5 to the right and 4 up. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Here's A prime. Okay. Then 1, 2, 3, 4, 5. 1, 2. Here's B prime. And then 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4 up. Here's C prime. Whoa, 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 whoa. 4 up. My apologies to all who were offended. There we go. Okay, now we want to reflect over the line x equals 2, negative 2. Okay, so my line x equals negative 2 is right here. If I could trace it accurately. Okay, so we got to reflect over this line. So 1, 2, 3, 4, 5 to the right. So A prime is 5 to the right. A double prime needs to be 5 to the left. So 1, 2, 3, 4, 5. That's going to be A double prime. Okay. That means that one is 8 to the left. So we need to go 8 to the right. There's B double prime. Okay, C is 4 to the right. We need to go 1, 2, 3, 4 to the left. There's C double prime. So we've translated 5 to the right and up 4. That was the rule I came up with. Then I reflected over the line x equals negative 2. Then we wanted to rotate 90 clockwise, I said. Okay, so let me write out my points here. So A double prime, B double prime, and C double prime. A double prime is negative 7, 2. Okay. B double prime is negative 10. Yep, negative 10, 2. Okay, and this one's going to be negative 6, negative 3. So to rotate 90, we switch them. So 2, 7, 2, 10, and 3, 6. Okay, that's step 1. Step 2 is to figure out the signs. So let's look at it. A right here is in quadrant 2. We're rotating 90 clockwise was the rule I said. I put 90 clockwise. So when I rotate 90 clockwise, I'm going to be in quadrant 1 here. Let me erase. This was the line we reflected over. This blue one. So 90 clockwise here, we're going to be quadrant 1, so it's going to be positive, positive. So we can put a point at 2, 7. Okay, that's A triple prime. Okay, I didn't think ahead very well here. It looks like B triple prime is going to be off the page, but that's fine. Okay, here's B triple prime. I'm sorry, A triple prime. Okay. Negative 10, 2, so 210. B is also in quadrant 2, so when you rotate it 90 degrees clockwise, it's going to be in quadrant 1, so it's positive, positive. So 210 would be somewhere here. That's B triple prime. And then C triple prime, that's in quadrant 3, so we rotate 90 clockwise, we're in quadrant 2. The signs for quadrant 2 are negative, positive, so it's going to be a negative 3, 6. And again, the reason it looks like this, okay, the reason it looks like this is because the stretch, right? The board stretches vertically, so it looks a little off. Okay. The last step here was to a scale factor of 1/2. So if I have another color that works, that you can see, probably not, but let's try it anyways, is we multiply all of these by 1/2. So this is going to become 1. It's going to become 3.5. Can't really see that. It's okay. 1, 5. And then negative 1.5, 3. So 1, 3.5. That's going to be B triple prime. Sorry, that's going to be A triple prime. a quadruple prime. 1, 5 is going to be B triple prime, quadruple prime. And then negative 1.53 is C triple prime, quadruple prime. Okay, we've shrunk this. So here we made our own triangle. We could have made it wherever we wanted. We had our own translation, which we did x plus 5, y plus 4. We then reflected over the line x equals negative 2. We then rotated 90 degrees clockwise. And then we contracted it by a factor of a half, or did dilation by a half, which made it get twice as close to the origin or half as far away from the origin. Okay, and so that would be our level 4 question, where you do your own and you show me you know how to do these and come up with your own rules. Okay, so that's level 4. I didn't think this would take 36 minutes. I kind of probably took too long in the beginning, but again, probably skipped over it anyways. So any questions, come in on Monday or early Tuesday, and we'll go over them before the test.